So if we're trying to find the inverse of a function algebraically, our first step is that we switch x and y in the equation, just like we've been doing. We switched x and y in the table, we switched x and y on a graph, we switch x and y in the equation. Then we're going to solve the equation for y. Now, that's the step where there could be some variation. It depends on what you have to do to solve for y. Sometimes it may be simple as just adding or subtracting, or just multiplying or dividing. We may get into needing to take a square root, or squaring, or something like that, but that's where there's going to be the variations there in step 2. And then the final step is you need to replace that y with the inverse notation. You need to actually identify, hey, this is my inverse. Okay, it's not my original function, it is different from the original function. So the first few that we're going to do here are going to be pretty simplistic examples, and then we'll get into some more complicated ones. First function we're going to find the inverse of is the function 3x. So first things first, it's g of x is the way that it's been written. G of x is equal to 3x. Well, just remember, g of x is just a fancy way of saying y. Okay, g of x, h of x, f of x, those are all just fancy ways of saying y. So when we switch x and y, we're going to have x equals 3 times y. And then we're going to do whatever we have to do algebraically to get y by itself. So in this case, it's being multiplied by 3, so we're just going to divide by 3. So we have x over 3, or just be aware that x over 3 is the same as 1/3 times x. Those are equivalent to each other. That is our g inverse of x. Oh, thank you. Okay, g of x is a fancy way of saying y, so replace it with y. Switch x and y, so that says x is equal to 3y. Get y by itself, divide by 3. X over 3 is the same as 1/3 x. So either of those are acceptable forms for g inverse of x. Now, if you ever want to know, did I actually find the inverse correctly? Graph it. Okay, you can graph it on your calculator. You can graph it using the Desmos calculator. Type in your original, type in your inverse, type in y equals x, and look for that symmetry. Y equals 1/3 x. Oops, make sure your x is not in the denominator. So this is the y equals x. You can see the symmetry. If you need to, you could pick some specific points and make sure that, like here, 3, 1 shows up. So 1, 3 should be on my inverse. Okay, it is. So that's one way you can test to see if you found the inverse correctly. Okay, let's do one that's got a little bit more to it. 3x minus 7. 3x minus 7, let's find the inverse of that function there. This time it was labeled h of x. Again, that's just a fancy way of saying y. So switch x and y. We get x is equal to 3y minus 7. Trying to get y by itself, solving for y. So we start by adding 7 to both sides. And then, like in the previous problem, dividing by 3. Now, x plus 7 over 3 is fine. Just be aware that that is the same as 1/3 x plus 7/3. You can put each term over the 3. It's the exact same thing. And that is equal to our h inverse of x. I'm fine with either one if it's a multiple choice question, you gotta recognize that those are equivalent. What type of functions have these been? What would we call these functions? Other than inverse, what type? If we graph them, what would they look like? Linear. Okay, these are linear functions. The original is linear. The inverse is linear. The original is linear. The inverse is linear. Let's see if it still applies when we have a fraction. 3/5 x plus 4. K of x is equal to 3/5x plus 4. So again, start by switching x and y and solve for y. So first step here, we subtract the 4. Now, we're going to do the same thing that we did before, but since that is a fraction, instead of dividing by a fraction, dividing by the fraction is the same as multiplying by its reciprocal. So if I look at this, instead of dividing by 3/5, I multiply by 5/3, it's the same thing, because 3 times 5 is 15, 5 times 3 is 15, 15/15 is 1, so that cancels. So whenever you have a fraction, don't divide by a fraction, multiply by its reciprocal. So again, you could leave it in this factored form, or you can distribute the 5/3, so 5/3 x minus 20/3, either one of those is the inverse function of k. Still linear. Okay, this is a linear equation, this is a linear equation. Mx plus b. Just because it's a fraction doesn't mean that anything's different there. All right, let's look at one that's not linear. Okay, now the computer was not being friendly to me when I was trying to type this in. This is what it would look like on a printed page. Okay, x minus 3 over x minus 2. It just really wasn't cooperating when I was trying to fix this. So we have f of x is equal to x minus 3 over x minus 2. Nothing about the process changes except for how we actually solve for y. So when we switch x and y here, we get x is equal to y minus 3 over y minus 2. This is a little different. We haven't had two y's before, so we're going to have to figure out how to deal with that. First thing we have to deal with is one of them's in the denominator. Okay, we got to get it out of the denominator. So we are going to multiply both sides by that y minus 2 because it's going to get it out of that denominator. When we multiply by y minus 2, that's going to cancel. Go ahead and distribute the x. Okay, go ahead and distribute the x here. So we get x times y minus 2x is equal to y minus 3. We're trying to solve for y. Now we have y on both sides. So let's get our y on one side and the other stuff on the other side. So it really technically doesn't matter which side we go to with it. I'm going to move it to the left side. So I'm going to subtract it from both sides. So I have xy minus y. I can't do anything with that because they're not exactly the same terms. Minus 2x equals negative 3. I said that I need just y on that side, so I'm going to move that 2x. It was negative, so I'm going to add it. So So we have xy minus y is equal to 2x minus 3. We're almost there. I know it doesn't quite look like it, but we're almost there. All right, we're trying to get y by itself. We have two of them that we can't put together. But if I look at this as a factoring problem, these two terms that I can't put together do have something in common, though. They both have a y. So I'm going to factor out that GCF of y. When I factor out a y from xy, I'm left with x. When I factor out a y from negative y, I'm left with a negative 1. And now I'm ready for my last step. To get y by itself, it's being multiplied by x minus 1. So I can divide both sides by x minus 1. So I get my inverse function is 2x minus 3 over x minus 1. My inverse function is 2x minus 3 over x minus 1. So we have not covered these types of functions yet, but this is called a rational function. We will have an entire unit on it, but this is a rational function, and its inverse is also a rational function. It has the same form, just the numbers are in slightly different places. A rational function has a variable in the denominator. Is a simple definition of what a rational function is. But the original was rational, the inverse is rational. All right, so that's really honestly the most complicated inverse that you'll have to find. The next couple of examples aren't nearly as complicated. Okay, let's find the inverse here. If our original function is f of x is equal to x squared, 4x is greater than 0. So I'll explain the parentheses here in a minute. For the moment, just write it down. Okay, so let's start our process. F of x is just a fancy way of saying y. Switch x and y. We get that x is equal to y squared. We need to solve for y. Y needs to be by itself. Right now it's being squared. What's the opposite of squaring something? Square root. What are we supposed to remember when we take a square root? What little detail are you supposed to remember when you take the square root of a number? What's the square root of 4? Is it only 2? Negative 2. You got to consider the positive and the negative. Here's where those parentheses are coming into play. If x is greater than 0, is that positive or negative? Positive. If something is greater than 0, that means it's positive. So when we take this square root, what's in parentheses there is saying, well, you only need to consider the positive square root for the inverse. If the parentheses had said for x is less than 0, then our inverse would have been the negative square root of x. Okay, so what's in parentheses? This really only applies to square roots. Okay, it really only applies to square roots. If it's greater than, it means consider the positive square root. If it's less than, consider the negative square root. Okay, so two different scenarios there, but same function. Okay. All right, so we started with a squared function, a quadratic function, and its inverse was the square root. Oh, what if we start the other way around? Let's start with the square root. Let's see what we get for its inverse. If our function is f of x is equal to the square root of x plus 3. Again, f of x, fancy way of saying y, switch x and y. So we have x is equal to the square root of y plus 3. We're trying to get to that y. It's stuck inside the square root, so the opposite of square rooting something is squaring it. So if we square both sides, we get x squared is equal to y plus 3. And then we can subtract the 3, so x squared minus 3 is equal to f inverse. So we started with a square root. Its inverse was a quadratic. Think about what undoes a certain function. You start with the squared, square root's going to fix that. So its inverse is a square root. Start with the square root, squared is going to undo that. So you're going to end up with a quadratic for the inverse. Okay, let's look at one similar to the first one that we did. Our original function here is negative x squared minus 5. We've got for x is greater than or greater than 0 again, so positive square root. So let's start the process. Switch x and y. X is equal to negative y squared minus 5. So here we need to add the 5 first. Before we can square root that, the y squared has to be by itself. Right now it's got a negative in front of it. So we need to divide by -1, which is just going to change our signs on the other side. And then we're going to take the square root. So we have the square root of negative x minus 5 is equal to the inverse. I took the square root. I only needed to consider the positive square root here because it was x is greater than 0. Now, that doesn't change the signs of what's under the square root. Okay? I'm just talking about the positive or negative in front of the square root. It doesn't change anything that's under it. And you may be thinking that's a whole lot of negative under the square root. I thought we couldn't take the square root of a negative number. You are correct. But think about if x were -3. If x is -3, then -3, well, that one's still not going to work because that's going to be 3 minus 5, so that's a negative. So that doesn't work. How about -6? Okay, a -6 is a positive 6. 6 minus 5 is 1. We can take the square root of that. Okay, so it's okay that there are negatives under that square root. You're just going to have limited values. All right, one more. H of x is equal to the cube root of x minus 4. Now, before we jump into this problem, I want you to compare the way this one is written versus b. Okay, that square root on b went all the way over the +3. This cube root purposefully is short. It's only over the x. That's why I like to put a little, I call it a little tail on my square roots and cube roots and whatever root I'm taking to show what is under that root and what's not under that root, because it's going to make a difference here. All right, so when we switch x and y, and we're trying to solve for y, we do not cube both sides first because the cube root of y is not by itself. It has to be by itself before we can do the opposite operation. So we have to start by adding 4. Then we can do the opposite of taking a cube root, which is raising it to the 3rd power. And we have our inverse. H inverse of x is x plus 4 cubed. Let me show you the graph of this one to emphasize what you should be looking for and if you got the order right. Okay, so if the original is the cube root Where's my cube root? Where's my cube root? Will not do that. Oh. There we go. I had to go over here to functions, and it has a little n on the square root. That's what lets me do the cube root. All right, cube root of x minus 4. That was my original, right? Yeah. Okay. And then my inverse is, this is the correct inverse. Okay. So if I look at that, you can see the symmetry. If I had cubed it first and then tried to add the 4, notice those are definitely not symmetric. I can see the shape is looking right, but I do not have that mirror reflection that I need. So that means I need to go back and check my order of doing things. That plus 4 needs to be inside, not outside of that cube. Okay, the order matters. Any questions about that? Okay, last thing before I turn y'all loose on some practice, let's just talk about this really quickly. These terms are not in the correct order. The instructions say match each function with the type of its inverse. Okay, so if we start with a linear function, what did we say that its inverse was? Linear. Okay. If we start with x cubed minus 7, what is its inverse going to be? A cube root. So that one was in the right place. X plus 2 over x minus 3. That was a rational function. Its inverse was rational. If we start with a square root, its inverse is going to be quadratic. Okay, so what operation will undo the main operation that you're looking at the moment? Okay, that's what's going on there.